Welcome to this lesson on proving shape properties. In this lesson, we are going to be using the different formulas that we have used, distance, midpoint, and slope, to prove properties about geometric shapes. So first you need to determine what formula to use in each problem. So you have a little a cheat sheet right below. So for distance, you're going to be looking for things about the lengths of the sides, the perimeter of the shape, the type of shape, like is it a rectangle or a square, does it have congruent sides, and then area. For midpoint, the only time you're really going to use midpoint is to determine if the diagonals of a shape bisect each other, because it would be the middle of both diagonals. And then for slope, you're going to be looking for parallel or perpendicular sides, or if it has a right angle. Okay, so number one, determine if the triangle is scalene, isosceles, or equilateral. So that would be the type of shape, and it's based on the lengths of the sides. Remember, scalene has no equal sides. An isosceles triangle has two equal sides. And an equilateral has all equal sides. Okay, so in order to determine if the sides are all equal or all different, we need to know the distance or the length of all the sides. So I need to know the distance from A to B, the length of line segment AB, from B to C, and from C to A, using the distance formula. Okay, so you can write it out in your calculator, or write it out on your paper, or type it in your calculator. I'm going to write them out here just so you have them. So from A to B, so I would say 8 minus 4, x sub 2 minus x sub 1 squared, and 4 minus 5. And you can do the work for each, and you should get 4.1. And I'm going to do the same thing for B to C. So I'm going to start with C, so 7 minus 8, and then 8 minus 4. All right, I'll give you a second to type that in your calculator and do any work. All right, and you should have gotten 4.1. And then the same thing for C to A. All right, so 4 minus 7, 5 minus 8, and you should get 4.2. All right, so as you can see, I have two equal sides, so this is an isosceles triangle. All right, the next one says to find the perimeter of the triangle. So perimeter again would be the distance formula, because I need to know the length of all the sides. So I need from A to B, from B to C, and from C to A. So pause the video now and go ahead and find the distance of all three sides. All right, so for AB, you should have gotten 5.1, for BC, 5.7, and for CA, 5.1. And then I just need to add those three up to find the perimeter, which is 15.9 units. All right, for number 3, do these 3 points create a right triangle? Okay, so to determine if it's a right triangle, we need to figure out, is there a right angle? Which means two of the sides would be perpendicular. And the formula that tells us if two sides or two line segments are perpendicular is slope. We're looking for opposite reciprocal slope. So I'm just going to find the slope of all three sides. I'm going to start with AB. Remember, slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, so that's negative 3 over negative 4, which is 3/4. And I'm going to do the same thing for BC. So 2 minus negative 1 negative 3 minus negative 2. Lots of negatives here. So that's 3 over negative 1, so that would be negative 3. All right, and then CA. So I'm going to do 2 minus 2. And 2 minus negative 3. So that would be 0 over 5, which is 0. All right, so none of these are opposite reciprocals. That means there are no perpendicular sides, so this is not a right triangle. All right, number 4, determine if the diagonals of this parallelogram are congruent. So if they're congruent, they're going to have an equal distance. So we're going to be using the distance formula. Now, if you think about a parallelogram, let me just kind of draw one out here. So A, B, C, D. The diagonals would be A to C and B to D. So I don't need to do all 4 sides, I need to do the diagonals. All right, so go ahead and pause the video now and find the distance from A to C and then from B to D. All right, so using the distance formula, I got 7.1 and 7.1. So they are congruent. That would be yes, they are equal in length. All right, number 5, determine if the diagonals bisect each other. So that would be midpoint. Because if they bisect each other, they're going to the middle of both. They're cutting it into 2 equal pieces on both sides. And because I'm talking about diagonals, I'm going to do A to C and B to D. And remember, midpoint, you add the x coordinates and divide by 2. Let me actually move this over a little bit. Okay, so x coordinates over 2, y coordinates over 2. So negative 6 plus 6, that's 0. 0 over 2 is 0. 2 plus 6 is 8, divided by 2 is 4. All right, so then we would do BD. So negative 1 plus 1 is 0, divided by 2 is 0. 7 plus 1 is 8, divided by 2 is 4. So that would be yes, because they had the same midpoint. They are cutting each other in half. All right, number 6, prove that the points of the quadrilateral create a rhombus. So we need to talk about the properties of a rhombus. Remember, a rhombus has all equal sides, so that's going to be the distance formula. And if we determine that it has all equal sides, then that's great, but that could also be a square. So to prove it's not a square, we need to prove that there are no right angles, and that would ensure that it is a rhombus. So we also need to do the slope. So I'm going to list out my sides here. Now you may need another sheet of paper to do this work, but we're going to do the distance of all 4 and the slope of all 4. So go ahead and pause the video now and try that by yourself. Okay, so for the distance, I got 5 for each side. So that does prove that it has all equal sides, but it still could be a rhombus or a square. So I needed to do slope. So for slope, I got positive 4/3, negative 4/3, positive 4/3, negative 4/3. Now, these are opposite slopes, but they are not opposite reciprocal slopes. So I do not have any right angles. So that proves it's not a square. So therefore it is a rhombus. All right, let's try a couple other examples. So find the area of the triangle with the following points. So let's go ahead and graph this. So there's A, B, and C. Oops. All right, so we want to find the area of this triangle. So area, remember, is 1/2 base times height. And if we're looking at this triangle, it has to be a right triangle to use this formula because the base and the height have to be perpendicular. So this could be my base and this could be my height because this has to be the right angle here because obviously these are not right angles. So let's find the length of AB and the length of AC using the distance formula. All right, so we can use the coordinates right here and substitute them into our distance formula for A to B and for B to C. So go ahead and pause the video and try that now. Okay, so AB, I got a distance of 5.7, and AC, I got a distance of 10.2. So area equals 1/2 5.7 times 10.2. That gives me about, let's plug it in here, 29.1 units squared because it's area. All right, and then in the last example, find the area of a rectangle with the following points. All right, so let's graph this. 0, 4, 4, 2, 1, -3, -3, -1. So go ahead and graph it and connect your points. Oh, I see I did this one wrong. There we go. All right, so area is length times width. And you can do either because we have two, doesn't matter. I'm just going to pick, let's see, area is length times width. So I'm going to pick A to D as my length and A to B is my width. And I'm using the distance formula here. So go ahead and pause the video now and find the distance of both of those. All right, so for my length, I got 7.1, and for my width, I got 4.2. So 7.1 times 4.2, multiply those together. And you get 29.82 units squared. Okay, you can go ahead and stop the video now and try the practice and check it with your teacher.